Hi guys, welcome to the video for chapter H7-2. This one's called The Screamer. There's some things that you're going to need for this lesson, so I'm recording this video for those of you who are at home right now to make sure that you understand what it is that you need to do. You should have your notes packet here, so this is the page from your notes packet. Then there's also a resource page in your Schoology folder that has a prompt that looks like this one. It says The Screamer. The top there, and then it's got a little story problem. And then on the back side of that, you will see it has a picture of a Ferris wheel. And most importantly, down here at the bottom, you will see there is a little ruler down here. We call this the 1-unit ruler. Okay, so you'll probably need to have that all printed out. You can even cut out this ruler so that you have it available to you when we start doing some of the measurements. So let's go ahead and let's get started. So looking at our notes page here, it says our objective for this lesson is to read and analyze a story problem about a ride called The Screamer. We're going to use measurements to find a pattern and help to discover a new type of function. It says obtain a copy of and read the Screamer problem. Okay, so I'm going to go ahead and do that here, and then we'll go through the rest of those directions. This is the Screamer problem. I'll go ahead and read it to you.
Hurry! Let's get there before the line gets too long, shouts Antonio to his best friend Renee as they race to get on the Screamer, the newest attraction at the local amusement park. It's only been open for 1 day, and already everyone is saying it's the scariest ride at the park, exclaims Antonio. I hear they really had to rush to get it done in time for summer. Antonio whistles as he screeches to a halt in front of a huge sign that says, "Welcome to the Screamer, the scariest ride on Earth." The picture below it shows an enormous wheel that represents the Screamer with its radius of 100 feet. Half of the wheel is below ground level in a very dark, murky pit with water at the bottom. As the Screamer rotates at dizzying speeds, riders fly up into the air before plunging downward through blasts of freezing air, hair-raising screams, and sticky spiderwebs into the pit where they splash through the dark, eerie water on their way back above ground. Renee and Antonio wait impatiently to get on the ride, watching passengers load and unload. New passengers get on and strap themselves in as others emerge from the pit looking queasy. The ride rotates 15 degrees to load and unload the next set of riders. As Renee straps himself in, he remembers Antonio's ominous words. I hear they really had to rush in order to get it done in time for summer. Sure enough, just as the ride plunges Renee and Antonio into the greasy water, they hear the piercing scream of metal twisting. Sparks fly, and the pit fills with smoke as the ride grinds to a halt. To escape, all of the riders must climb vertically to ground level from wherever they got stuck, either up from the pit or down from the dizzying heights. Sounds like a ride I'd want to go on, right? All right, let's look back at our notes here for a second. 712A says, use the 1-unit ruler to measure the escape heights on the model. The seat could be in the pit, high in the air, or right at ground level. Remember that his position depends on the angle of the ride's rotation when it broke down. The radius of the model wheel will be referred to as 1 unit. That is, a model height of 1 unit corresponds to the actual height of 100 feet on the ride. So an actual height of 80 feet on the ride will be represented by a measured height of 0.8 units on the model. Record your data on the table provided below. So this is what it's referring to, is this little ruler. I have it in orange here so it'll stand out for you. But what you'll see here is this entire thing is 1 unit. Okay, so it is equal to the radius of the Screamer model that you'll see on the back side of the resource paper. And so each of these, like 0.1, right, is really going to represent 10 feet in real life. 0.2 is like 20 feet. 0.3, 30 feet all the way across. So this would be 100 feet when we're measuring. Okay, then you're also going to take it, and we're going to go through and do some measurements, and then you're going to record all of this information on the table that you find on here. And we'll record it together here in just a moment.
So I'm going to get out my sheet here so you can hopefully follow along. All right, so this is our interpretation of the screamer that we're using in class and you're using it at home. Okay, so remember, halfway across this half here, right? This half down below is underground, this half is above ground. So anybody who's trapped in any of these seats all the way around have to climb vertically. So if they're stuck here, they're gonna have to climb vertically to get to ground level, or so it's gonna either be up or down as you're going through. So what we're gonna do is we are going to go around and we're gonna measure the distance from each of the seats to figure out how far each rider would have to climb. So starting out right here at 0 and 360 degrees, we already know that these guys are already on the ground level. So they are going to climb, we'll just go ahead and say this one's going to be 0 feet. Okay, so when I measure that there, right, I guess I would say it'd be like 0 units too, right, because it's already on the ground level. So I'm going to measure this next one, right? So this is where at 15 degrees, and you see there's a little white circle on each of the I don't know what you call it, the little carts on the Ferris wheels that's going around. So we're going to measure to that. So from halfway up to that there. So when I take my ruler, I'm going to put it halfway, then I'm going to measure up to that little white circle from halfway up to about right here, right? And so when we're saying here that this is like where they're going to be climbing from, we can measure that's like 0.1 to here, 0.2 to here, and then 0.3 there. So it's between 0.2 and 0.3. And we can go ahead and estimate to one extra decimal place. Let's say that's about, I don't know, about 0.27. Okay, so let's right here, this one's about 0.27. Okay, then let's go to this next one where they would have been trapped at 30 degrees. So we're measuring from this midline, where it goes across here, from 180 degrees across to 360. We're measuring up to that white dot. So at 30 degrees here, that one looks like it's about, I don't know, we'd say 0.5, right? So in real life, that'd be 50 feet, but let's just go ahead and write 0.5. Okay, so that's what you're doing here as you're going around and measuring. I'm going to go ahead and measure a few of these here, and you can pause the video or you can, just follow along and do it with me. This one, you see, it's going to be more than 0.7 and less than 0.8. So it's just a hair past 0.7. You could say 0.7 if you want, or 0.71. It's up to you. I'll say it's 0.7. Let's look at 60 degrees. This one, as we're going up, right? So we're on that line. We're going all the way up here. So it's between 0.8 and 0.9. I'd say maybe about 0.88. Okay, so write that there. This is 0.88. Now we're at 75 degrees, right? So we're going to get up here, and this one is less than 100 feet, but looks like it's more than 90. So let's say about 0.96-ish. Okay, so let's write that in there, 0.96 units. When we get to our 90 degrees, right, when we're going all the way to the top, right, this should be the farthest. This is exactly one radius length. So we know that this one should be 100 feet or 1 unit as we measured out on here. So everybody sees those measurements there. Let's go ahead here and take a peek here at our table. Right, I'm going to set this in here, see if I can get this all on here. I'll move this over just a hair. So you'll see here on your table, it asks us for several things. It says our degree of rotation from 0. So starting here at 0, this is going up 15 degrees. You got that. Going up to 30 degrees. There that is, and it goes all the way down here. Then it says our measured height. So our value of y should be between 0 and 1. So this is what we got on our ruler when we measured. And let's go ahead and write those in. I'm going to write them in pencil. So I know that at 0 degrees, we said that we were 0 units. At 15 degrees, we were at 0.27. At 30 degrees, we measured 0.5. And then at 45 degrees, we said we were about 0.7. At 60 degrees, we were at 0.88. At 75 degrees, we said 0.96. And then at 90 degrees, we said we were at exactly 1. Okay, so let's go ahead and translate those to actual feet in real life here, right? So 0 units was the same thing as 0 feet. Remember, this little ruler represents 100 feet. So like down here, we know that this is 100 feet. That would make this 96 feet. This would be 88 feet. Looks like 70 feet, 50 feet, and 27 feet there. Okay, now what we need to do here is we need to keep going. So you can, follow along with me, or you can go ahead and start measuring through on your own there, then fast forward and double check your answers. Remember, these are estimates, so you may not have the exact same values that I have, and that's okay. So let me jump back over here. Okay, now as I start to go through this here, I notice that like when I get to my 105, when I measure that there, that looks like it's about 0.96. So write that here, 0.96. Let's do 120 degrees. So when I measure up here, this one looks like it's about, it's between 0.8 and 0.9, so about 0.88. Let's do one more here. Let's see. 135 degrees looks like it's about 0.7. Now, what are you noticing here? Right, all these new measurements here that are on the left side are looking like they're going to be the same heights as what we had on the right side, right? Because we're going in 15-degree increments. So each of these seats looks like they're going to be at the same height. We get to that point now where we don't even really have to measure, because if 30 degrees was 0.5, then I think 150 degrees would also be 0.5 because they're the same height. And then 15 and 165, I've got 0.27. And then 180 degrees, we know that we're at 0. So let's go ahead there and just add those onto our table. Which was 0. Okay, so we've measured halfway around that circle. Now what you need to do is you need to measure out the bottom so we can fill in the table on the right side. So go ahead and do that. See if you pick up on any other patterns. For instance, right, if I see here, if I'm measuring now, I'm going to be measuring down, right, from ground level downward. So as we do this here, this one looks like, if this seat was 0.27 up, this one looks like it's 0.27 down. So they're the same distance from, that ground level. So that might help us out a lot, right? But what would I want to put since I'm going underground? Is there a way to decipher between above ground and below ground? Maybe we call this a negative 0.27. And then that would make this one a negative 0.5. So let's go ahead and fill out the rest of that chart. Feet. I didn't write feet on the other side, but not a big deal if you don't have them written in there. Just write the numbers down. All right, so we got the hard part done here, right? We've collected some data. And now go ahead and flip over to the back side. says graph your data on the graph using columns 1 and 3. Okay, so when you're looking at the points on there, right, so that'll be the first column is the degrees, and then these are the actual, so these are your degrees on the x-axis, and then these are the actual feet measurements there. So when we're looking at that there, right, I kept saying that these were below ground, so maybe we want to go ahead and include, right, since I put the negatives in here, maybe we want to go ahead and throw our negatives in there so that we're talking about being below ground, okay? So let's go ahead and do this now, and let's see what it looks like. So we don't have every single angle measurement increment on here, but you know that halfway from 0 to 30, right, would be, or 15 would be, so you're going to have one halfway in between too. So just take your time and graph them. If you need to flip back and forth, go ahead and do it. So I know I had one here at 0, 0. 15 was about 27, so I'm going to just kind of estimate it. At 30, I was at 50 feet, so I know that's going to be about here. At 45, I was about 70, which would be about halfway between 60 and 80. And so just go ahead here, take your time going through and plotting all of these.
Let's see, 135 at 70, 150 we're at 50, 165 we're at 27, 180 we're at 0.
And then keep going, go ahead and put your bottom in. So 195, it looked like I was at negative 27, which should be somewhere right in here. 210, at negative 0.5, so that was like negative 50 feet. 220.
25 we're at negative 70 feet. 240 we're at negative 88 feet, so right in here. 255 we're at 96, negative 96 feet. 270 we're at negative 100 feet. And then I start to get working its way back down.
All right, so if we take it here, let's just lightly kind of connect the dots. Hey, that looks pretty good there. All right, so that we just plotted the data of how high, right? Remember, this is like our height above ground, above or below ground, that each rider was stuck at when it broke down. So our height here is on the y-axis, and our x-axis was the degrees. So suppose you were asked to graph 20 more points onto the graph. What kinds of strategies, patterns could you use to make it easier? Well, hopefully we can kind of see, what's going on in between, so we could find some angle measures and things in between there and kind of estimate the heights. Okay, or if it started to go around again and got stuck, we could also come up with, more points beyond 360 degrees. Okay, now it says 7-13. The function from 712 is a new parent function. Write an equation and use it to calculate the height of the triangle. Does this calculated height seem reasonable when you compare to the data that you collected in problem 7-12? All right, so let's look down here. We've got a triangle. This angle is 40 degrees. It looks like this side length here is 1 unit long. And they want us to figure out what the height of this rectangle is going to be. So we could just, call this like h over here. What's the height? So in order to find that there, if we think back to our, right triangle trigonometry, or our SOHCAHTOA, right, we've got this angle, so we're talking about the opposite side, and one would be like our hypotenuse. So we could probably calculate that by doing the sine of 40 degrees is equal to h over 1. So the sine of 40 degrees is equal to h over 1. Now, there's not really a need to cross multiply there, right? Because if I have h over 1 and it equals the sine of 40, that just means that h is going to equal the sine of 40 degrees. That's pretty nice there, right? Because since our hypotenuse is 1, that works out. Okay, so let's see here what the sine of 40 degrees. You probably want to get out your calculator. I'm grabbing mine. Hopefully it'll show up well on here. Okay, so I'm just going to use my 84 at this point. So first thing, make sure your calculator is in degree mode. We want to be in degrees. So mine is in degrees. So I'm going to go ahead and say the sine of 40 equals, it says 0.6427. So we're going to just go and round to about 0.64. Okay, and they're asking, does this make sense when we think about our graph? So how many feet would that have been if we had measured it? Well, it would have been about, what, 64 feet? And if we look on our graph here at 40 degrees, it'd probably be about somewhere in here. When we look up here, what are we going to be at? Well, if we go up and extend it up here, it looks like it's right around 60 to 65, you know. So is this a reasonable, well, is our estimates reasonable? Absolutely there, right? Because this is actually a calculated height, 0.64 when it's 40 degrees. So that would kind of fit along the pattern that we've come up with. Let's move down here to this next slide. It says, write an equation for the escape height, h of theta, for any passenger. That is, for any angle of rotation on the screamer. Well, now we know here that we could use this function here. And if we know the angle measure that somebody was stuck at, we could plug it into this function, or the sine of theta, and that should give us the height that the person was stuck at, that they had to climb down. Okay, so the next part says enter the data from the first two columns. Okay, so make sure you're paying attention to that. From the first two columns into your graphing calculator. Okay, it says adjust the viewing window so that you can see all of the data, then graph h of theta on top of that. How well does your h of theta fit your data, or h of theta fit your data? It kind of rhymes. All right, so you'll see here that there are instructions here for the inspire over here. So if you need to use the inspire directions, please go ahead and do that. I'm going to show on the 84 because I know the majority of students have 84s this year. Usually it's the other way around, but you know, we're going to go through and do what we can here. So first thing, okay, I'm going to clear it out. So here's how we do put in data on a TI 84. To the stat button, everybody sees the stat button on here. Okay, it's like the third column over, second button down, not counting these ones up here, right? So we're going to press stat, and we're going to go to edit. So we're going to hit number one, edit there. And you see we've got these lists. Okay, so first thing we're going to do here is we're going to enter in what will be our x coordinates. And our x coordinates are going to be our degree measurements. So we're going to go in here and we're going to type in 0, 15. Okay, I'm going right down this list here. 30. Okay, you see I've typed in all of my angle measures from 0 to 360 degrees. Now we need to use our second column from our table here. So we're using the one that has the decimals in it. Okay, we're going to test, see how close we are to our actual sine values. So let's take this here, and you're going to type in 0, and you're going to do 0.27, and you're going to do 0.5. Okay, and go ahead and make sure you're careful not to skip any. Okay, so hopefully you have everything in there. So the next thing that we're going to do is, if you're using, you know, TI-84, you're going to go to y equals. Okay, you can go ahead and clear out anything that's in here. I'm going to go ahead and clear that out there. Okay, now we're going to go in and we're going to do a stat plot. So you see that there's these three options up here. If you do second y equals, okay, it's going to allow us to turn those on and off. So we're going to go in here and we're going to turn on number 1. So in here, we're going to press number 1. Okay, and first thing we need to do is highlight enter, turn it on. Okay, now there's all these different kinds of graphs that you can do on here. There's like box and whisker, line graphs, bar graphs. We're going to keep that first one here that looks like, it's got a dark background with little, little points on it there. So we're going to take that, and then we're going to go down here, and we're going to make sure that, our X list is list 1, and our Y list is list 2. That's what it should be if you look back here at our stats. We go to number 1, edit here, right? List 1, list 2. So list 1 will be our X's, list 2 will be our Y's. So I'm going back in, second Y equals, going back into number 1. So that all makes sense there. And then, whatever you want to do here, you can make your points that it graphs whatever shape you want there. Okay. So the next thing we'll do then is we will say graph. Okay. Now your graph will probably end up looking like this. You're like, what is that? It doesn't really do anything. Well, the other thing that we have to do is we have to adjust our window. Okay. We want to make our window so that we can see all those points that we just put on there. So you need to go to window. And we think about our X minimum, right? Think about what's the smallest degree that we had on our table. We had here 0, right? It went from 0 all the way to 360. So our X min is going to be 0. Our X max is going to be 360. Okay. The scale there, I mean, you can do by whatever you want. Let's actually do by 15s. Let's do by 15 since we did our angles by 15s. Now our Y values, okay, this is where we have to be paying attention here, right? So we started at 0 and we're going by 0.2, 7, 0.5, 0.7, 0.8. So we go all the way up. Our greatest value looks like it's 1. And our least value looks like it's -1. So our Y min, we want -1. And our Y max, we want +1. And then for our scale, it doesn't really matter on this one here. That's fine. And we don't really need to worry about the rest of it. So let's go ahead and go into graph now. And you're going to see there is the data that you just measured out, okay, displayed on the calculator. Okay. Now, what it's asking us to do, if I jump back here, what it's asking us to do is to take it, and they want us to graph the actual sine function to see how close our data matches the sine function. So now what you're going to do, you're going to press Y equals. Okay. And under Y1 here, our first function, I want you to go ahead and type the sine. And we'll just go ahead and put X. You don't have to worry about putting in like a theta. We're just going to put an X in there. And now when we graph it, you're going to see it's graphing that function right over our data. So it looks like our data was pretty good. Mr. Boyd's a good measurer there, right? So hopefully yours matches up pretty well. Okay, so you see all those points. Okay, so how well does our h of theta fit our data? I'd say it does pretty well, right? It seems to match up well. So it says view the table for h of theta on your calculator and then record the outputs of h of theta in the open column on your sheet. So remember, we came up with estimated measurements when we were measuring on there. So if you flip your notes packet back over, now we're going to just record what the actual sine values is for each of these angles. So here's how you're going to do that. Hopefully you can still see everything on here. Let me just move that over and that over just a little bit. Move it up. Okay, so here's how we're going to do this. So this function is already typed in on our calculator. Y equals the sine of X. You're going to go in here. If you want to look at the table, okay, we can go second graph, and it'll bring up our table. Now your table, who knows when the last time you used it was, and it's probably got all kinds of weird stuff on there if you've not used it before. So what we're going to do is we're going to set up our table so that it will help us to be able to write these things down much more easily. So to do this, make sure you're following along. Second, then the window button to go into table set. Table start. Well, our table started at 0 degrees, so let's go ahead and put 0 in there first. Now it says delta table, so it wants to know what increments do you want to go by. Well, since these are going by 15s, let's go ahead and put 15 in there. And then we don't need to worry about these two options here. That has nothing to do with what we're doing. So we're going to go back to second graph to look at our table. Now you're going to see the actual sign values. Now these are all still, approximate because they're rounded decimals. So these numbers would continue to go on and on. But now we have a better idea of what it would be. So we'd say here our first one, right? So it's actually 0. This one is actually 0.2588. So we'll round it to 4 decimal places there, okay? Then 30 is exactly 0.5, so that one was spot on. 45, 0.7071. 60 be 0.866. You can put the 0 on the end there if you want, because we're rounding to 4 decimal places, but heck, I'll do it since I said it. And then we had 0.9659. Next one, 90 is exactly 1, so that one was exactly right. And then just go ahead and keep scrolling down, and you can record all of these. And remember, you should start to see that pattern here, right, where you start to see those numbers repeating themselves. So go ahead and you can jot those in. All right, so you've gone through and you've filled out all of that information. Okay, so that is all I'm going to ask of you today. Okay, that's all I'm going to ask of you today is to fill out that information. Okay, and then there's some practice looking at some stuff with some trig on your homework. Okay, so your homework should be worksheet H7-2.